everyone for joining us. Welcome to the C2 Smart webinar series. I'm John Patinos, the project manager at C2 Smart. Just a heads up, this webinar is going to be recorded and uploaded to the C2 Smart YouTube channel. We'll have time for some questions at the end of our presentation today. If you do have anything you'd like to ask, please feel free to type your questions in the chat and I'll read them out loud at the end of the webinar. Today, I'm happy to introduce Dr. Kelvin Cheu, Associate Director for Research at C2 Smart. And at the University of Texas, El Paso, a member of the C2 Smart Consortium, Dr. Cheu is a tenured full professor with the Department of Civil Engineering and directs the Border Intermodal Gateway Transportation Laboratory. He's joined by Dr. Okan Gurbuz, Assistant Research Scientist in the Research and Implementation Program at the El Paso office of the esteemed Texas A&M Transportation Institute. Today's webinar is Sparkman, the smart parking app, optimizing parking on college campuses, based on research sponsored in part by the U.S. Department of Transportation. Professor Cheu, please take it away.
Thank you, John, for the introduction. Today's topic is parking. Parking has been a research topic of UTEP's Transportation Lab for the past 3 years. Actually, the idea came mostly came from Okan, the main speaker for today, as it's a PhD dissertation research topic. The parking research has been sponsored by US DOT, University Transportation Center in parts over the past 3 years. So today what you will see in the presentation is a very quick overview of the first 2 years results, plus what Okan has done in the last year or so, from March of 2019 to February of this year, as one chapter of his dissertation. And this work is sponsored by C2 Smart. For today's presentation, the content research was sponsored by C2 Smart. And so let me introduce Okan. Okan came from Turkey, and he came to El Paso to do his Master of Science in Construction Management. And while doing this, he fell in love with transportation, and he decided to do a PhD in transportation, and also partly because he was attracted by the C2 Smart activities and the research topic. So, and as soon as he started his PhD research, he had identified parking as an issue that nobody has been paying attention to, and he made himself an expert in the country in the short span of 2 or 3 years. So he graduated in December last year, successfully with a PhD degree from UTEP, and he's now working as an assistant research engineer at Texas Transportation Institute in El Paso office. And he continued to collaborate with UTEP and C2 Smart on continue his research. And in fact, right now he is part of the team member of ongoing research that we're moving from university parking to study downtown parking issues. So without further delay, I'll hand it over to Okan to make his presentation.
Thank you, Dr. Cheu and John, for the great introduction. And good afternoon, everybody. This is Okan. As they mentioned, I'm an assistant research scientist at Texas A&M Transportation Institute in the El Paso office. And I involved in this project while I was a PhD student at UTEP. And today I will talk about the project funded by C2 Smart, namely Sparkman, a smart parking management tool. So here is the outline of today's presentation. I will start with the background of the parking problem, the factors that motivated us to pick that topic, and then I will share the research objectives and the methodology and the tasks. Then I will summarize our previous work and zoning and zone pricing methodology that we developed. Then I will talk about the name and the product of our study, which is Sparkman. And then I will share the student survey findings that we conducted at the University of Texas at El Paso campus. And I will finally end my presentation by giving the impacts, limitations, and potential further work. So let me start with some interesting findings that we got from from our literature review that shows how important parking is. So according to American Automobile Association 2017 survey, it has been found that an average car spends 23 hours and 12 minutes per day in parking instead of moving. So this in other words, this covers more than 96% of its daily time. In another study, it has been found that it has been stated that in United States, parking takes up more space than the state of Massachusetts. And when we consider the cost of parking, we also found that to build a new open parking lot, a stall in average costs between $1,000 to $3,000, and this range jumps to $8,000 to $15,000 for a parking garage. And in another study, it has been found that for operation and maintenance, universities in general or in average pay $400 per stall for an open parking lot and $1,200 per stall for a parking garage annually. So with those findings, we can say that we can conclude that parking is important from time, cost, and space perspectives. For that reason, every city and university has a parking department. But unfortunately, although this concept is that important, there was still no tool, model, or methodology to guide university parking offices in making their important decisions. And I said was because now with our study, there is at least one tool that can help, that can support the university parking offices. According to National Center for Educational Statistics, collected in 2017, there were 310 universities which offer bachelor, master's, and PhD programs with total campus enrollment of at least 10,000 students. So as seen in the table, in the slides, majority of the university population, 85%, are the students. So therefore, any policy that should take into account the students first, and especially the commuter students are most likely to contribute to large-scale parking issues on a campus. So any policy or any solution to address the campus parking issue should take into account the parking needs of the students first. That's why we focused on as an initial step. We picked our focus group as students on campuses. So these are the three research objectives that we addressed for that project. The first one is to develop a methodology that's to zone parking lots for commuter students and set permit prices. And the integrated zoning and pricing methodology is then called zoning and zone permit pricing, in short Z2P2. The second objective was to integrate and program the already developed campus-wide total demand and the base price models with the Z2P2 methodology into a user-friendly software tool named Smart Parking Management, or in short, Sparkman. And the last objective was to conduct a survey to understand students' preferences among different ITS applications for parking on university campuses and use the survey data to develop the level of service criteria for parking. So these are the tasks, and the research work was divided into 3 sequential tasks to reach the objectives I just read, and the work performed and the output of each task will be presented today in today's presentation. So the first one is to develop the Z2P2 methodology. As you all know, that a parking zone consists, especially on a campus, consists of one to several adjacent parking lots that have the same or similar type of permit sold at the same price. So from the perspective of a commuter student, the attractiveness of a zone depends on the zone's permit price and the last mile travel time. In other words, the travel time from the parking lot to the final destination of the student, like a classroom. In the first task, we developed a methodology, as I just mentioned. It's called Z2P2, and its aim is to group several adjacent parking lots into a zone, and at the same time, set the annual permit price for that zone based on some features of the parking lots. And the second task was to code and test the tool called Sparkman. This task incorporated the Z2P2 methodology that was developed in task 1, and the two previously developed models during my PhD studies, which are called total demand and the base price models. And then they all incorporated and coded into a software, and we call it Sparkman. And it's a very user-friendly and an Excel-based tool. The last task was to conduct survey on intelligent transportation system preferences among university students and set the level of service criteria. This task was to conduct a survey, and we got the IRB, Institution Review Board, approval from UTEP, and the survey was conducted on campus between February 27 to April 25, 2019. And you can see the welcome box of the tool and the flyer that we developed for the student survey. Before going further, I want to talk briefly about our previous work before developing the Z2P2 methodology. We first tried to answer two questions, which are answered together by developing two different macro level models. They are called total demand and base price models. What we did is we focused on the large universities, which all have enrollment more than 10,000 students. And as I mentioned earlier, there are 310 universities based on National Center for Educational Statistics in the United States that are considered as large universities. And they all can serve from undergrad level to PhD level. So we focused on those universities and tried to gather their data to develop our macro models. And all the data we collected was gathered from publicly available resources and mainly from the university's websites. Because of the limited availability at the end of the data collection, we were only able to gather 208 of the university's data. Then we thought that it was enough to develop macro models. The first model is called total demand model. It is aiming to predict the percent of students who will bring their cars to school. And we use the beta regression analysis. Beta regression is a specialized type of linear regression, which only gives the output values between 0 and 1. Since we are trying to get the fraction or the rates of the students, it seemed us the beta regression is the best way to do the analysis. And then when we run the model with different input parameters we collected from 208 universities, we have found that the significant parameters are the temperature, the tuition fee, the proportion of undergrad students, the proportion of part-time students, and the median permit price. The second model was called base permit price model, and we use this time the Tobit regression. It is also a special case for a linear regression, which truncates the outputs that doesn't allow to get negative values. So if you try to get a value with like annual permit prices that has to be always positive, it is good to use the Tobit regression, and it also helps us to find really good results. And it has been found that the predicted base permit price depends on the factors shown in the slide. The first one is the campus setting. We have only two choices. urban or suburban, the cost of living that comes from the United States General Service Administration per diem rates, the proportion of undergrad students, the faculty-student ratio, and the proportion of students who purchased the parking permits in the previous year. So as I mentioned, these two models were developed before the C2 Smart funded projects began. And the first task of our study was to develop the zoning model to distribute the base permit price to different lots. The question was for this task, how should the parking lots on campus be grouped into different student parking zones? And what should be the prices for these student parking zones? And the answer that we developed was the Z2P2 methodology. So we have the price from the base price model I just showed, and or the university parking offices can set a price, but this is only one number that will represent the median permit price. But generally, university campuses have various lots that are all spread across the campus with different features or different attributes. So we thought that to be more fair, the zoning or zone pricing should take all elements of different lots into consideration. So this slide demonstrates the potential elements of each lot that may have an effect. And starting with the walking time of the student, which is the most important aspect. This is the walking time of the student from the parking lot to the final destination. Or at some universities, the rate of the bicycle use is high. So also the students who use their bicycles to travel to campus, the cycling time also matters. Then the value of time of the student is another important aspect that we have to take into account. The parking lot features, whether like the parking lot provides the shuttle service, the parking infrastructure, whether it's a garage or it's an open surface lot, and other university parking office policies that all have to take into account, because these are all affecting the pricing or zoning of different lots. So to demonstrate the methodology, the UTEP campus was selected as the case study, and there are 21 different parking lots on the campus, but there are only 4 different parking zones for commuter students. And to conduct the methodology, we selected one point which is geographically located in the center of the campus, but this can be changed. It all depends on the user of the methodology. Then walking and the cycling times for each parking lot to that pre-selected point were all measured. And based on the student survey results that I'm going to explain in a minute, the fraction of walkers or bicycle users were found. And additionally, the total shuttle service time for the parking lots, which provides free shuttle service, were also found. And it was assumed that the students who have chance to take the shuttle service to reduce their walking time from the same parking lots will select to use the shuttle service instead of walking. And to find the student value of time, the main references used were USDOT value of time calculation and another study conducted at the University of California, Los Angeles by Dr. Cheu, and we used those approaches to calculate the student value of time, and we link that value of time to median household income of the city where the university is located. So for our case study, we used the US Census Bureau data for the median household income of El Paso, and we have found that the average UTEP student value of time is 13 cents per minute. So in other words, UTEP students save 13 cents if they spend 1 minute less for their one trip, or they lose 13 cents if they spend 1 minute more. And if you consider the entire year of going to campus, this value then goes up to around $33 per year. So after extrapolating that one trip saving or loss to the entire year, the difference in values were applied to all different parking lots on campus. And you can see in this slide the graphical representation of the findings. And we did the calculation twice. One with the price that we have found based on our base permit price model, and the other one is with the actual base permit price that UTEP parking office was using on the day of the report writing. And as you can see, the orange bars represents the actual prices. The blue and the white bars are demonstrating the alternatives. And also you can see here that some parking lots are underpriced, whether some are overpriced. To see the overall effect of the proposed permit prices, and another revenue graph for university parking office was generated on top of it, and assuming that the number of students who will purchase the permits will not change and they will keep on buying the same parking lots, the revenue changes are shown with the bar charts in the middle. So it seems that parking office will have much revenue for each alternative compared to the current application. And all these findings allow us to develop a product, which was the second task, which is also called Smart Parking Management Tool, or in short, Sparkman. This tool is basically used the three models that we have developed and I just showed you. And it gives the output to predict the demand, the estimation of the base price, and it also has the capability to set the zones and prices for each parking lot or each parking zone. The Sparkman's target users are the staff of the university parking offices. Since all universities provide Microsoft Office to their staff as a standard software tool, we thought that it is best to develop a tool using the Microsoft Excel, and we use Microsoft Excel macro and Visual Basic for applications for the programming language to develop this easy tool. And the current version of Sparkman, we call it version 1.0, was coded and we tested. And then we prepared a how to use video for the first time users. And here is the video. Let me open it. It's just 4 minutes.
Hello, welcome to a Sparkman software user tutorial. Thank you for testing Sparkman prototype. After you download the software, please find the folder where it has been saved and open it. Sparkman has coding functions behind it. To begin using Sparkman, please click the Enable Content button. You may close the welcome box to start using the tool. This is the dashboard of Sparkman. The left-hand side contains the cells buttons for you to enter the corresponding information. On the right-hand side is the output panel, which gives the results after the information is entered. Let's get started. First step is to select the location of your university by typing the city and then finding it within the drop-down menu. Second step is to select the university setting. The scroll-down menu will allow you to select one of the alternatives given, city or rural. Third step is to enter general information about your university. Click the About University button and a new window will open up. On this new window, You are asked to enter the latest information about your university, such as annual in-state tuition and fees, number of student enrollment, number of part-time students, number of undergraduate students, number of full-time and part-time faculty, and last but not least, the number of student parking permit holders. Click the Save button to save the information entered. You may now click the Exit button to continue. The fourth and final step is to enter the parking lot's information under the Pricing button. Each parking lot serving commuter students should be entered to the software with the following information: the name of the parking lot, number of available stalls for students, annual student permit price, approximate walking time from the parking lot to the center of campus, the type of parking lot, whether it's a parking garage or an open surface lot, needs to be selected. If parking lot does not provide shuttle service, just save and continue with the next parking lot. Parking lot provides shuttle service. The average shuttle waiting time, shuttle drive time, and walking time from closest shuttle to stop to campus core are all extra information that will be required. After entering information of all parking lots, to close the window, click Exit. The results will immediately appear in the Sparkman output panel located on the right-hand side of the dashboard. The expected demand reflects the number of students that the model has predicted. The current base price is the median price based on the existing prices you have provided. The model base price is a calculated base price found by the model. The table on the right-hand side lists all the parking lots, their current prices with two proposed prices. In the first option, model outcome base price is used to set the prices for different parking lots. Alternatively, Sparkman lists the proposed prices using their current base price at the last column. You can check, compare, and prefer one of these alternatives. Finally, before entering new data, please make sure you reset the Sparkman software by clicking the Reset Form button. Thank you for watching and testing the tool. You can submit your feedback by using the link provided. We look forward to hearing back from you.
So this tool was shared with more than 50 universities so far, and we asked them to give their feedback for the software. This evaluation was conducted with the help of the members of Campus Parking and Transportation Association, or in short CPTA, which has 163 education affiliate members from 70 different universities. And those members are the responsible officers of the university parking offices. So what we did, we sent emails, and that include Sparkman version 1, and we send the email with the attachment of the Excel and the link to the instruction video that I just showed, and the link to the website where the respondents can enter their comments and give the feedback. And alternatively, the evaluators could provide written feedback by replying to our emails. And the initial email requests were followed by email reminders in this year, and we made some telephone calls that was provided in the official membership roster. And these calls were to remind the invited members about the evaluation. Also, it gave us the opportunity to explain the project and what is expected from them. And you can read some of the original comments in this slide. And based on the comments we received, we are planning to upgrade the tool and make it in a better way for the users. So the third task, as I mentioned, was the student survey. A survey was conducted on campus to better understand the student needs for parking and to develop methods for new models. Today, I'm going to share the results by using the infographics, and you can reach this in the page of the project at the C2 Smart website. So the survey was conducted in spring 2019, and it was an online survey, and we got the UTEP IRB approval for that. We distributed the informative flyers that I showed in a previous slide, and then we reached out to campus newspaper, and they made a story about our study. And we also got some support from professors all around the campus, and we finally ended up with 1,022 participants. And among those, there were 533 had a parking permit. So to talk about the student classification, we have found that 33% of them are juniors, 27 of them were seniors, 12% of students were grad students, and 86% of students, they reported that they are full-time students. To understand the travel patterns of the students, we asked them their modes of travel to campus, and it has been found that 80% of the students on campus, they prefer to drive, and only 8% walk, 6% carpool, 5% took the transit, and only 1% of the students, they cycle to campus. In another question, we asked them how early they reach to campus before their first classes start. And 61% of the students stated that they come within 30 minutes, and only 10% of students reported that they come 1 hour earlier than their first class starts. This is the second part of the infographics, and we have found that among the permit holders, majority of them have the blue permit, or in other words, it's called perimeter permit, followed by garage, removed, and silver, and the other permits. The most interesting finding from the survey was the rate of students who park in the neighborhoods. So among that 80% of the students who drive to campus, 29% of them reported that they park in the neighborhood of the campus. That also clarifies our doubt that during we were checking the UTEP permit sales. And about the shuttle use, it has been found that only 20% of the students, they prefer to use free shuttle service. And also we asked students about the most preferred improvements they would like to see, and we listed them the intelligent transportation system technologies that are related to parking. The first choice was about the permit sales, and then they would like to see the permit sales are all year around, and they can purchase a permit as easy as buying a concert ticket or booking a hotel room, which are all online. And the second most selected alternative was the flexible zone, which in other words indicates that student participants do not want to be restricted to a parking lot whole year. Flexible zone will allow them for some days to park closer, in some days in a remote lot, or all depends on their daily needs. So about the factors that drive students to purchase particular parking permit, the color of the parking permit, the 40% of the students reported that the cost of the permit is the main influencer, and it is followed by the walking time, the ease of finding a spot, and time to take the shuttle, and the time to take the shuttle plus the walking time. The last question of the survey that I didn't include in the infographics, we asked the student participants to relate the level of service in parking with their search time. The participant was asked to select the maximum allowable duration in minutes for each level of service grade. And the question was, assuming that the effort to find a parking spot may be described by A to E grades, with A corresponds to a very easy and E corresponds to very difficult. For each of the grades, select the value that in the student's opinion represents the maximum duration for that grade. And after removing the incomplete answers and the outliers, we aggregate the results, and the survey findings were used to define the level of service criteria for linking the parking search time. And this table was produced. The level of service A, which was found as less than 2 minutes, the level of service B is 2 to 4, C is 4 to 7, D is between 7 to 10 minutes, E is between 10 to 15 minutes. And any time greater than 15 minutes in search time was found unacceptable, or in other words, level of service F. So when we wrote the proposal about our parking study, former UTEP president heard about the project, and she supported us with asking the Center for Institutional Evaluation, Research and Planning Department, or in short CIERP, to provide us the de-identified student records. And we met several times with the vice president and the director of CIERP to inform every step what we have been doing. And after we got the IRB approval, they provided us all student data for fall 2018, where there were 25,151 entries. And among those, there were 9,430 of them have the parking permits. And our survey had, to recall, our survey had 1,022 participants, which had 533 permit holders. So to validate our survey, we checked the color of permits students have and the students' classifications. The type of the permit owners seems the sample is accurately distributed among the alternatives. However, when it comes to student classification, it looks like our survey was taken mainly by sophomore and junior level students. On the other hand, following models, our plan with this data, we plan to develop a parameter of student classification dividing by undergrad or grad. So from that point of view, even the classification seems enough to develop further upcoming models. So to talk about the impacts of the study, I would like to give some other interesting facts about university parking. And although parking is an important infrastructure, and all the information that I just shared, there are very few experts or researchers in the academia in the United States that are dealing with the university campus parking. And also, we believe that the parking overall is an under-researched and underfunded topic. We can say by looking at TRB has only a subcommittee. Highway capacity manual doesn't have any chapter on parking. There are no questions about parking in FE or PE exams. And although ASHTO and IT manuals have some parking geometric design considerations, none of them covers the most important aspect that I just showed, which is the parking search time. And we had, especially I had the opportunity while I was a student, I had chance to test my models on campus, like a living lab, and we got a really good number of survey participants, and we aim to lead the nation in parking research. And afterwards, similar tools can be used for all other universities and especially for downtowns or city centers. And you can see in the slide, we already have 2 journal publications from our parking study. So like every research topic, our study has some limitations. And since our main focus was the commuter student parking, which forms the largest demand, we did not study, or we did not put focus for faculty and staff parking. And moreover, although the survey results demonstrated that the campus parking has an effect on neighborhood parking, especially in our case, we haven't included that in our study yet. And our zoning and zone pricing model had an input for shuttle bus frequency, as I showed, but we didn't propose a tool to optimize the shuttle service, and these are all can be considered as a further work. So as a follow-up, this year we have been funded by, again, C2 Smart for another parking related project. And this project focuses on developed service that we developed for parking, and we are expanding it to a performance measurement for parking. So this year's project aims to develop level of service analysis procedures that estimate or measure the average search time for selected types of different parking facilities. And additionally, alternative evaluation methodologies for parking operations based on available technology is going to be explored. To summarize, what are we doing right now is I can list the objectives of this ongoing project, and these are to develop level of service analysis for procedures for open surface parking lots and conventional multi-story parking garages, and develop a ConOps of PMS in smart parking garages, and explore PMS for street parking using the existing smart technology. And besides that, these are some other potential future work derived from our study. Some of them we have already started working, but some were left for the future. This study can be expanded to faculty and staff parking, and an entire campus parking can be handled by the single algorithm. The class schedule, as you all know, that has a huge effect on the hourly parking variations. That can be also studied. Therefore, the class schedule can be staggered through the week to optimize the parking demand. And then, as you know, that the parking offices, they sell more permits than the actual capacity of the parking lots, which is called the overselling. And this can be studied to find the optimum overselling ratio value for each parking lot. And the overall demand distribution can be predicted by a zone demand distribution model. And for the urban campuses, the unfulfilled demand behavior can be investigated with a closer look to the neighborhood parkers. And of course, finally, the benefits and drawbacks of intelligent transportation systems implementation on university parking systems can be explored for the future work. So these are some selected references for our study. And yeah, thanks for listening. This is all we have for today. We are open to hear the questions or comments you have now.
Okay, thank you so much. That was great. And I just wanted to say I love the music accompanying the Sparkman video. It makes me want to use the app immediately.
Okay, good.
I have, so for those who want to ask our presenters any questions, please use the Q&A feature at the bottom of the Zoom screen. I have a few questions already. So first question. So for those of us who don't think much about parking, can you talk about the effect of having almost 30% of student drivers parking in the neighborhood of the UTEP campus?
So you think that you have a house close to campus, and but you cannot park on your roadway, or you cannot park on the sidewalk, and some other guys are parking. So we are hearing a lot of complaints from residents, and also so you know, especially in urban campuses, the relationship with the community is very important. And for example, in our case, El Poso is a crowded city, but UTEP is the largest campus, and it has kind of serving the whole El Poso. And if you do not have really good relationship with your community, then how you can attract more students or convince more students to persuade to come to your campus. So it's really important to have a good relationship with the residents. Besides that, students who are looking for neighborhood parking, they are causing extra congestion in the neighborhood. So we are located, as I mentioned, in kind of urban area. So students who want to come to campus, sometimes they are dealing with congestion around the campus because of the students who are looking for neighborhood parking.
Yeah, I love that, and I'm immediately thinking about college towns all over the United States. And impacts also on like environmental impacts, congestion, accidents, which is things I don't usually think about in terms of parking, but just pricing parking is so important. So seems like this is a win-win for all parties. And if you look at the revenue bar graph you presented, like potential like increase in revenue for UTEP. Can you talk a little bit more about the plans for implementation of Sparkman at UTEP, like for UTEP's parking, or else elsewhere, maybe in El Paso or your next year's project?
So as I mentioned in the presentation, we first, of course, since we were in UTEP community, the first thing we did is we shared with the tool with our parking office, and then we shared with the CPTA, Campus Parking and Transportation Association. And so I think it is still like the officers are still want to like see how it is going, and they want to make sure that it gives the reliable results, and they are still testing. Although we have really good feedbacks that it is very user friendly and it gives the user good results. But I'm not sure it is like, I cannot say that it's going to be implemented next year, because you also know that it is really hard to change even 1 penny of the permit price, because you need to convince a huge community of students, staff, faculty, because it affects a lot of people.
Sure. A couple more questions here. How did you define the values used in each bin of your level of service, your LOS? For example, you asked you defined certain answers from difficulty to finding a space as easy to find, difficult to find. How did you constrain these answers, or is it just truly subjective?
So we use the general transportation perspective that, and we didn't tell students it is level of service, because as I mentioned, we conducted this survey campus-wide, and majority of the students are not engineers. So we didn't say anything about level of service. In our question, you may recall, it is more about their effort to find a parking spot. So we asked them to think about their grades. So since if you are a good student, you got an A, right? If you fail, you got an F. So we tell them, grade the parking. So if it is a really good experience, grade it as an A. And they say that from their perspective, students' perspective, it is subjective. They say that what will make you give grade A if you have an effort of this amount of minutes? And we remove the outliers, incomplete answers, and we come up with, okay, students think that less than 2 minutes is grade A, or in other words, level of service A. More than 15 minutes, it's unacceptable. I cannot wait more than 15 minutes in a parking lot for searching for parking, and it is a failure of the infrastructure or level of service F.
Okay, another audience member asks if you can, I guess, with Sparkman output, can you talk again about the two different outputs, the difference between the two columns of output, and what the calculated prices mean from the perspective of a user?
Okay, I can go back to the slide and show the. Okay, so we have two alternatives. They are following exactly the same methodology. Nothing is different. The methodology put the base price in the middle, and if you and link it with the walking time, and if you walk more, you pay less. If you walk less, you pay more. The methodology is that simple. The difference within the prices is we thought that university parking officers may think that, okay, my price is the best price as the medium price. So please do not change it. So one alternative is that one. The second alternative, as I mentioned, is the base permit model that we developed before this study. So it takes into account the macro statistics and the regression analysis results, and it gives you another like output as the median price. But university parking officers are like they're okay to change like select one of the alternatives. They can select their own median price, or they can select what we propose with our model. So these two different prices are providing the alternative prices for the users.
Okay, and we have time for one last question. Do you think you'd be able to extend this model to autonomous vehicles? Maybe incorporate this into, yeah, I know, incorporate this into autonomous vehicles for further optimization of parking prices?
So I've been working with parking like for 3 years, and we had some proposals for autonomous vehicles with parking. So autonomous vehicles is a question mark, and autonomous vehicles with parking is double question mark, because people think that, some researchers think that with autonomous vehicles, there will be less car ownership, there will be more carpools, or with autonomous vehicles, there is no need to have a parking stall very close to anywhere or any destination. So the car can drop you off, and it can go and find a parking spot by itself, basically, with the autonomous vehicle. So I think it can be a very future work that there might be, from the perspective of university campuses, what would be changed with the autonomous vehicles is, I think, all the parking spots within the campus, or all the parking spots in the perimeters, will be converted to buildings for the universities, and the autonomous vehicles will drop people, and they will go and park in the remote zones, because there's no need to have a small last mile thing, because everybody will be dropped very close to campus. Maybe this time, as parking experts, we need to think about where should be the drop-off zones, or how should we design the drop-off zones or curbside management. This is going to be something different with the autonomous vehicles. But I think Sparkman in the near future will not answer the autonomous vehicles implementation.
Sure. So thank you so much, Professor Cheu and Dr. Gurbuz, for your presentation today. Looking forward to speaking with you again for your next year's project. Again, this was the result of their past year's project sponsored by the US DOT. You can check out this and all of our other webinars and seminars on the C2 Smart YouTube channel. Thank you, everyone, for joining us today.
Thank you.
Thank you.